there any question from the past lectures? Any question? Okay. In the past lecture, in the last session, we talked about security in wireless LAN, and today we will continue the content of chapter 8, and we want to talk about security in cellular networks, especially security in 4G and 5G technologies. The first thing that I can say is that when we talk about 4G cellular network, there is a SIM card in all cell phones. Okay, using the stored information in this SIM card. This SIM card has some information. Okay, when my cell phone tries to join we talk about this Naima. When my cell phone tries to associate to a cellular network, it sends the information inside its SIM card. Okay? Using this information, the stored information in the SIM card, the base station or Node B in cellular networks in 4G, in LTE, we try to authenticate the cell phone. Okay, so firstly, my cell phone try to join to a new base station, to a new BTS. To do this, the cell phone sends the stored information in the SIM card to the base station. Using that information, the base station would try to authenticate the cell phone. Okay, this is something different. If I wait. Excuse me. No, Zainab, I stop my microphone to check something. Excuse me, we talked about this section in the last session. Okay, here. We should start from here. Today we want to talk about some security mechanisms, some security tools. Look at this list here. We start with some principles, key principles in the networks in the network security area. Then, and we talked about cryptography, authentication, integrity, and we show you how we can do this, apply these items. Then we start to talk about a sample, a secure sample in application layer. Then we talked about security in layer 4. Then we talked about security in layer 3. And finally, we talked about security in the physical layer, layer 1 and 2. Okay. And now, in this session, we want to talk about security as separated tools. Okay. Today we will talk about firewall and IDS, two separated and powerful security items. They are necessary to keep a network secure. The first item is firewall. What is firewall? Firewall is a service sit on the network edge. Okay, find the network edge. The firewall sits in that place, on the edge of the network, the border of network. The firewall tries to isolate the internal traffic from the external traffic. It means that the firewall tries to stop sending information from the outside of the network into inside, or sending information from inside toward the outside. The firewall would block those traffics. We don't need to send information to the outside or receiving information from the outside. Okay? But there are some exceptions here. For example, I need access to my email server in the university, or I need access to the web server website of for example, university, or I need access to Golestan website in the university. So I need to access some of those services inside the network from the outside. Okay? Just we need some services. So we can set their information, those information in the firewall. Okay, firewall, let these traffics to pass the border, but rest of traffics should be blocked. Still, they should be blocked. So the firewall only allows just a few packets, a few traffics, passes the border. The rest of traffics would be blocked, would be stopped. Especially those traffics come from the outside toward the inside. Those traffic, especially those traffics. they should be blocked. Why? Inside my network, I know that most of the peoples, maybe all of the peoples, are trusted guys, are good guys, so I can trust them. But outside of this network, there are several bad guys, several untrusted guys. They decided to access my properties, attack me, to rob my properties, and something like that, to damage them. Okay? So, the firewall stands between our network or administrated network and the public internet. Somewhere around this place. Something between these two networks, between the public internet and my network. My internal, my private networks. Okay, so firewall sits here. Why we need firewall? As I said, there are several bad guys and several attacks started in the internet, and their traffics would write to my network. For example, an attacker can make a DOS attack to my network. Okay, so maybe some people try to access to my private information. Maybe someone try to get an unauthorized access to my network. So if I want to prevent DOS or DDoS attacks, something like sync flooding attacks. Okay. If someone try to make some modification on my private data inside of my network, maybe someone try to get an access to my network. Those access are unauthorized. So the firewall will try to act against these problems, preventing DOS attacks, preventing illegal access, preventing unauthorized access, preventing illegal modification, and something like that. The firewall only allows access to data for only authorized users, not all of people. So firewall is an important tool in my network for security. The firewalls had three types: stateless packet filtering, stateful packet filtering, and application gateways. Let me talk about each of those firewalls. The simplest form of firewall is stateless packet filtering. In stateless packet filtering, my firewall sits on the edge of network and this firewall has an access control list or ACL, access control list, ACL, and it checks each packet separately, one by one, packet by packet. It checks each packet, information in the packets, check the header of packet, especially the source IP address and the destination IP address, the source port address and the destination port address, and especially these items. The firewall would check these items with its access control list, and based on that access control list, it makes a decision about the packet. Okay, according to this access control list, I cannot accept this packet. I should drop it. Okay, according to this access control list, this packet is allowed. We can forward this packet. Okay, so the firewall, a stateless firewall, only address. So, excuse me. It only focuses on each separated packets, one by one. The source IP address, the destination IP address, the source port number, and destination port number. It just checked it. Check its access control list and make decision. What should I do with this packet? For example, here, for example, what should I do with ICP packets? What should I do with TCP sync or TCP acknowledge packets? Maybe the firewall check all of them. Okay. And then it can make a decision about that packet. For example, maybe someone says, maybe in the access control, we say that, okay, if we have a packet with IP protocol field 17 and this source or destination port 23, block this packet. It's not important if this packet is coming from outside to inside or this packet sends from inside to outside. It's not important. Just if the protocol field is 17 and the source or destination address is 23, just based on these items, block those packets. Or for example, if we receive a packet and you find that the acknowledge number in this TCP statement in the TCP header is 0. The acknowledge number is 0 in TCP segments. We should drop this packet. Why? Because these packets can be used for an attack, in an attack. So simply we set those information in the access control list, and the firewall will check it. Okay, this packet should be blocked or should be dropped. But how we make decision? How a firewall make decision on this case, on these cases? Firstly, in the security world, we have to create a policy list. In this list, we describe our policies. Okay, for example, our website will not be accessed from the outside. We should block that access to our websites from the outside. This is a policy. Okay. For example, only receives packets for the web server of the university, for example. Only those packets who are who send for the web server of the university. Or maybe preventing web radius from eating up the available bandwidth. Maybe preventing smooth DOS attacks, preventing trace route traffics, preventing ICMP traffic comes into our network, something like that. Okay. We made these policies based on some, for example, best practice, or I don't know, based on some previous experiments. We write these policies, and then based on these policies, we have to apply these policies into our firewall settings. For example, if someone says that, okay, no on-site web access, it means that I should block port number 80. I should block all outgoing packets with port number 80. Why? Because the port number 80 is used for HTTP services. So simply, I'm writing a rule. Okay, all of traffics sent to port 80 should be blocked. Or maybe someone says that, okay, prevent your network from being traced out. As we know, traceout is using TTL options to find the access toward a specific destination. Okay, so if I don't like traceroute traffics, it's simple. Just drop ICMP TTL expiration traffics. Or, for example, when I say that, okay, prevent smooth DOS attacks, these type of attacks is used by broadcast addresses. So simply I can I can drop those ICMP packets with broadcast addresses. In these cases, in these examples, I show you that if you are looking for policies, the managers in the organization, they define some policies, they write some policies, and then we have to apply those policies. Applying those policies in the form of firewall settings, especially. And this is an example of access control lists. For example, if my source address is 222.22/16 and destination is somewhere else, the protocol is TCP, and its port number is higher than 1023 with destination port 80. With I don't know, I'm not care about the flags, so these traffics are allowed. Okay, or maybe this one here, 222.22/16 outside of this network. The protocol is UDP. Source port number is higher than 1023. Destination port 53. This traffic is allowed to. Okay, and look at this one here, the last row. In this example here, the first 4 rows are cases with allowed actions. Is that those traffics defined in those rows are allowed to live, are allowed to pass the borders. And the last row shows that, okay, for the rest of traffics, look at this one, we have made decision about 4 types of traffics. But in the last row, we say that, okay, the rest of those traffics, the traffics that I don't know who they are. Okay, I don't know who are those traffics. Using the last row, in this case, we said that, okay, block all of those traffics. So simply just I need to define the information of those traffics and the action, the necessary action. Okay, these traffics are allowed, but these traffics are should be denied. In the stateless packet filtering, we only talk about controlling packet one by one. In this type of traffics, we never talk about the correlation between different packets. But in most of cases, this correlation is important. in stateful packet filtering, the firewall first look for the content inside the packet, and then it looks for the relation between the packet and the rest of packets. For example, we receive a packet with TCP sync flag. Okay, we know that this TCP sync flag is placed in somewhere that we want to start something new. But if we receive a packet with finish flag, FIN flag, this flag means that the connection is, we are trying to close the connection. Get this? We try to close a connection. Okay, so maybe someone's asking me, okay, have you a connection, a TCP connection? Yes or no? We receive this packet with flag, with finish flag. The finish flag is set to 1. Is it true? Yes or no? So in stateful, we make decision based on the content of the current packet and the status of the previous connections. We look for all of them. For example, I receive a packet with pin flag set to 1. It means that this is the last packet of this connection. Okay, the firewall can check its list. Have you something like this? Have a connection something like this? Yes. Okay, this is the finished packet. But if we receive no, we have not a connection with this information. That's very interesting. We have not something like this. We have not this connection. And we receive a packet with flag of finish set to 1. What does it mean? It can be an attack. So simply we drop that packet. The difference between the stateless and the stateful firewall is here. In the first case, we say that, okay, this is a packet, just check the packet, and if it's true, send it. But now we say that, okay, check this packet, but check its correlation too. Is it a true packet? Does this packet arrives in a good time, in a correct way or no? So simply we can active or deactive connections. and we can talk about those connections. Look at this one here. The first row is checked same as previous, but the second row, it needs to check the connection, and especially in the fourth row. In some cases, we will try to check the connection. It means that we should follow its state of the connection. But only we apply it for some connections, not all of those connections. And finally, in the last row, again, we can see delaying all of the rest packets. One more note here. In this case that you can see, we are using a whitelist strategy. Let's suppose that I have a firewall and now I want to set on my firewall at the edge of network. We can use two different strategies. The first one is using a blacklist, and the second one is using a whitelist. In blacklist, we can say, okay, block these types of traffics, this traffic, this traffic, this one. Okay, we have a blacklist and we only block those traffics. We only talk about those traffics and block those traffics. This is the blacklist strategy. But the important note here is that how can I prove that my blacklist is complete? There is no proof. You cannot prove that your blacklist is complete because of the nature of traffics in the internet. There are several billions devices connected to internet. So if somebody says that, okay, I'm using a blacklist strategy in my firewall and it works well, we can simply say that, okay, what about this address? Can your firewall react against this address? A random address, okay? Be sure that the blacklist strategy could not work correctly because I can't know all threats in the network against my in the internet against my content in the network. Instead of that, we can use a whitelist. In whitelist, we only say that, okay, these traffics are allowed, but the rest of traffics are blocked. You can see this strategy here in this case. Firstly, we define 4 different cases. Okay, we only use define those allowed traffic, and finally we say that okay, the rest of traffic would be blocked. The third type of firewall is application gateway. Application gateway is a very specific type of firewall. For only a few applications, just a few applications, we can define a gateway and says that okay, this type of packets, this family of traffics, you have to pass through this gateway. For example, look at this on here. We have a gateway here, and some specific traffics, some defined traffics should go to this gateway. And then after that, this gateway can send my information toward the outside. So the application gateway is the only channels to send or receive traffics from one application, one specific applications. For example, we can create an application gateway for Telnet protocol. All of Telnet protocols should control them from the authorization point of view. Mohammed Hassan said that here it will pass according to the instruction that I put in the network. Where? In the application gateway? Mohammed Hassan, you mean the application gateway? You are talking about this strategy? Mohammed Hassan. Overall, yes. My traffic should pass the firewall. So, and firewall would check it, would check the traffic. So if you find a way to bypass the firewall, then you can enter into the network without any check. And firewall sits in the edge of network, in the network border, right on the door of network. So if you find another way, another path toward the inside of network, another path to access the inside network, inside of network. So simply you can access to network without any disruption, without any limitation. So in application gateway, we only define gateways for some specific application, not the whole traffics, not for the whole applications, just for a few applications, a few specific applications, such as telnet, because we can use telnet to receive a remote access to an external item. The whole traffic of those specific applications should pass this way, only this way. If the routers, if the border router or a border firewall receives some packets from those applications, receive some packets, and say that, okay, these traffics, the source of the originator of these traffics is not the fire, is not the gateway. Okay, this one, this application here, this server here, the border router here. This router receives some packets where the gateway is not the originator of that packet. Those traffic are not sent from the gateway side. So simply this firewall can drop my packets. It's very simple. They can drop it. Why? Because this firewall only accepts the information comes from the gateway. This gateway is the only pass toward the border firewall, toward the outside. All traffic should pass it. This is mandatory. We have to pass it. Okay. So firewall is very important in all networks, but one more thing. All firewall have to make, all firewalls have to make decision real time. They receive a packet, they have to make decision about that packet real time, right at that time. So the firewall has a limited time to make decision. So they cannot check everything. Maybe, for example, in port scanning attack, we send some, as an attacker, okay? As an attacker, I send some packets, some different packets, to different port numbers of a computer, of a specific server, or of a specific computer, okay? If I receive a reply, that port number is open. Otherwise, it's closed. From the firewall point of view, the firewall see that, okay, this is a simple packet sent toward this destination, this system, this computer, this server. So the firewall would allow those traffic to pass the firewall. In this case, firewall couldn't check the correlation between this packet and the past one and the newest one. Maybe I can send those traffics, for example, with 1 minute delay. Okay, each 1 minute, in each 1 minute, I can send for the interrupt. Okay, so my firewall has some limitations. It cannot detect some things, or maybe something else. I receive an packet. The firewall can receive a packet with an spoofed IP address. Okay, so how can this firewall check this IP address? There is no way. It can. The firewall cannot check the real IP address. And also, we have some types of traffic, some types of application. They couldn't react, couldn't make a connection after a firewall, especially for voice services. For in voice services, we need some special proxy or some special gateways. Okay, we need those gateways or proxies. So in these cases, you can see that the firewall cannot be useful. Or most of the time, there is no defined rules for UDP traffics. Most of the time we only use firewalls with TCP traffics. You know, the firewall itself, the firewall has lots of limitations. And we need this item, we need firewall, but we cannot make trust only on firewalls, using only firewalls in my network. I cannot trust on them. We need something else, we need something more. If we are looking for security, we need something more than firewall. There are several attacks or several applications, several demands that a firewall cannot answer to those requirements, to those demands. Okay. What security tool in a network is intrusion detection systems. The IDS or intrusion detection system is a system in network with deep packet inspection capability. In firewall, we have a limited time to make a decision. So as we talked, the firewall cannot react perfectly. It has some limitations. Okay. Instead of that, we use. Excuse me. After your traffic enters to the network, your traffic passes the firewall, and after that, the firewall can do nothing. Look at this one here. My firewall is here. If a traffic passes this firewall, the firewall can do nothing. Okay. Instead of that, inside our network, we use IDS, intrusion detection system. This system has some sensors, some implemented sensors in the network. Those sensors try to gather information, the past traffics over the network, over different parts of networks. Okay? So I have some sensors. They are data gathering sensors. They gather, they save the same information over the network. They save a copy of sent information over the network. Something like Wireshark. Okay? In Wireshark, we capture those over the network. Here we have something like this. We have some IDS sensors. Those sensors capture the traffic along the network. Those past traffic over the network. Okay? So we implement those sensors in specific locations in the network, and using those sensors we try to capture traffics over the network. After that, after capturing those information, in another stage, we have an IDS server. This server will receive those captured packets, and it will try to analyze the correlation between different packets to find the relation between them. This work, finding relation between different packets, it's a time-consuming process. So the IDS system is not online. This process is done offline. Firstly, I capture traffics over the network, and sometimes, and in the future, maybe a few hours, maybe a few days after that, my IDS would check those captured traffic to find the correlation between different packets. the correlation between multiple packets. For example, the correlation between different packets from port scanning point of view. Finding correlation between different packets for network mapping. Finding the correlation between different packets for DOS attacks. This process is too time consuming, and using this process and finding those relations, we can find different types of attacks, especially different types of DOS or DDoS attacks over the network. As we read in the first chapter of this book, DOS or DDoS attacks are simple and regular packets. But the attacker or the attackers sends a huge volume of those simple packets toward a server. Okay, I can block those packets, some of those packets, because they are sending from different IP addresses, and I don't know which of them is a real request. Okay? So I cannot handle them in firewall most of times. Maybe just I can find some of those packets, but I couldn't find the source of those DDoS attacks in firewall. But in IDS, we have enough time. I can check the relation between different packets and then find the correlation between them and find the source of attacks, find the meaning of each of those packets, and doing something like that. And everything is offline. And also, those captured packets are captured in different positions, in different locations in the network. But as I talked, the firewall only can look the traffic in some specific position. For example, I set up a firewall in my border router. So that firewall only can check the traffic passes from the border. Or maybe I can set up a firewall before a main server. So that firewall only can see and can check the traffic toward that specific server. Okay? But here in IDS, we have a bunch of sensors. Those are distributed in the network. So the IDS would receive different packets from different positions in the network. They can make decision better than a firewall because they have more evidence. They receive more packets from different sites and different locations in the network. And after this IDS, we have something like something else. We call it IPS. IDS and IPS. Sometimes somebody called them IDPS. IDS and IPS, and sometimes somebody said that, okay, this is IDPS. The difference between the IDS and IPS is that the IDS is responsible to detect attacks, detects intrusions, intrusion detection system. The IDS only detects the attacks, and the IPS is responsible for intrusion prevention. The IPS reacts against that intrusion. This is the difference between the IDS and IPS. And sometimes we have some IDPS tools. The IDPS has two parts. Firstly, it detects intrusions, and secondly, it prevents the intrusion. But how? The IDPS can change the access. This IDPS can make modification on access control list of firewalls. The IDPS can modify the access control list of firewalls. It automatically update the access control list. Okay, this attack comes from this source IP address over this port number. So simply it would add a new record to the access control list. Okay, block this type of traffics. So this is the difference between the IDS and IPS. If we are looking for a secure network, we have to use different tools. For IDS, we need IDPS. For intrusion detection, we need IDPS tools. And these tools, it's better that these tools could handle access control lists of our firewall. Okay? And this is the last slide of this chapter. When we talked about security, we talked about different technologies, different protocols, different tools, and different aspects in a network. This area is too wide, and maybe some of you decided to work in this area. And maybe some of you are network administrator, so you need to know more about network security. You need to work more clearly, more deeply on this area. Okay, and this is the last slide. Okay, is there any question from this chapter? After this, we will talk about some parts of some parts in chapter 6. There's something, some just a few slides in chapter 6 after this, for in the next session. Okay? In the next session, we will talk about them. Any other questions? About the exam of this chapter, this chapter will be next week. Next week on I will announce the date. Okay, I will announce the date about. Okay, I will announce the time for the exam of quiz of chapter 8, this chapter. But I will schedule it for the end of next week. Next week. Excuse me. Next Tuesday, Wednesday, Thursday, next Thursday. Next Thursday. This date. Exam quiz of chapter 8 will be held on this date. If you have something to say about, if you have some points about this time, please write in the WhatsApp group. I know, but we have some more assignments too. No, next week is the last week of this term. is the next week is the 16th week of this term. Oh, excuse me. But from my is the next week is the 16th week of this term. Excuse me. This is the last week of this term, and after that, the final we will have the final exams. But from my point of view, you can send your assignment and your homework after the 16 weeks, after the next week. But for the quiz, no. Read for the quiz and do it at the time. At this time. Okay. Yes, you can upload with delay, but still we have some more assignments. Please pay attention. Still we have some more assignments. You don't need a DB account. Like that. Just open a simple file and write your information in that file. Or use a worksheet on Excel, Microsoft Excel, or something like that. Okay? Just write your information in a table. Okay, I have, for example, 50 different locations, and in these locations, I see this antenna with this RSS value, this antenna with this RSS value, this one with this RSS, and something like that. Just create a table and fill it. Just doing this. I don't look for something else. Just create a simple database on a simple file, on a simple table, not more. Any question? Any other question? Okay, I wish the best for you. And good luck. After day 16, yes. Day, in Persian, شونزه day. In Farsi, tamam. Yes. Okay, thank you and goodbye.